cause earthquakes and volcanoes, which is a, a very destructive natural phenomenon. As you can see, the volcanoes on the left and on the right, this picture, the fault or the break between the two tectonic plates when they diverged caused earthquakes. So it actually happens. Do you know that we sense many earthquakes? However, there are much more earthquakes that we don't sense. It just happens. This is because of the tectonic plate movement. And we will discuss in details earthquakes later. The second plate movement is the convergent boundary. Remember, we said they collide toward each other. So this collision yields different natural phenomena according to the crust that collide. If it's an ocean colliding with an ocean crust, or an ocean colliding with a continental crust, like at the second picture, or the third diagram at the end of the slide, which is the continental colliding with another continental crust. Imagine if an oceanic crust in the first diagram collides with another oceanic crust. What do you think will happen? One of these crusts might be less dense, so it will slide beneath the other. This sliding leads to what is called a subduction zone, the sliding of crust beneath another crust. This sliding creates pressure, and also it releases water vapor because it's oceanic crust. So the water vapor is released inside the lithosphere. This release of water vapor and pressure inside causes release or molten rock formation. So the magma or the molten rock formation, due to the convection current, moves upward. In the weak points of the crust, volcanoes erupt. Or when the oceanic crust meets another oceanic crust, or they collide in a convergent way, they can cause island formation beneath the ocean, where you find islands beneath the ocean. The second example of ocean and continent crust collision, it's in the same manner. Less dense meets a higher dense crust. It slides. The less dense slide beneath the higher, creating pressure difference. Pressure becomes higher, magma moves upwards, and volcanoes may erupt. And earthquakes may occur. The third diagram, which illustrates the continental crust colliding with another continental crust, they are of maybe the same density, so at the most probably most of the time here mountains form, not volcanoes. An example of a convergent boundaries are the formation of Himalayas mountain. Can you guess if it's a continent-continent or continent-ocean collision? Yes, it's a continent-continent collision because it formed huge mountain formation and no volcanic formation. This is due to movement of Indian plate with the China plate. Another very famous example is Mount Rushmore in USA. You know this mountain where the presidents of the United States are carved in the rocks of the mountain? Yes, it's because of the continent plates colliding with each other in a convergent way. Again, convergent way is that the continent plate meets another continent plate, they collide, and it causes folds or mountains to form. This movement causes earthquakes to form. Another example of a convergent boundary where continent and ocean plate boundary occurs, an example is Mount San Andres, because of Pacific Ocean plate meets the South American plate, or Mount St. Helens. This type of collision causes strong volcanic activity and earthquakes, as we've explained before. The third convergent boundary movement example, which is very famous in Japan, it happens in the ocean because an ocean crust meets another ocean crust, causing island formation and volcanic eruptions, and they are very strong. What about the transform boundary? A common example is San Andreas Fault in California. You see the line in this picture? This is the plate boundary where the two continents plates slide past each other, and it causes earthquakes to form. What are hotspot volcanoes? So, do all volcanoes occur at plate boundaries? Actually, no. Many volcanoes occur at hotspots. The very famous volcano, the Hawaiian volcano, occurs at a hotspot. It's not at a plate boundary, it's in the middle of the plate. So this is very important to remember that not all volcanoes occur at plate boundaries. They can occur at the middle of the plate. How might that happen? It's also because of the earth crust or plate movement tectonics. So what are the volcanoes? There are probably 1,500 volcanoes, so over 1,000 volcanoes that are active in the world, but not all volcanoes are active. There are much more volcanoes, but they're not active. So the active volcanoes are the volcanoes that have erupted recently and might erupt again. The second type of volcanoes, which are the dormant volcanoes, or the second stage of volcanoes, they are dormant. That means they have not erupted for a long time. However, they may erupt. Extinct volcanoes are volcanoes that have erupted thousands of years ago, but will never probably erupt again. So let's understand the different parts of a volcano. You here have the magma reservoir, which is the chamber where the magma moves upward when the volcano erupts. Inside the magma reservoir or chamber, the molten rock is called magma, but when it erupts and it comes out of the vent that surrounds the crater, it's called lava. Okay? Here we also have the ash cloud. You see the cloud, the gray cloud or gas? This ash cloud is composed of gases and dust, solid particles that comes out of the magma chamber. This ash cloud is very harmful because it has gases like carbon dioxide, silicon dioxide, solid particles, all of which are called pyroclastic material. Okay, so also the chamber, we can call it a conduit, but as we go upward, they give it another term called throat. However, all I want you to remember is that there is a reservoir of magma or a chamber where the molten rock magma is released upwards, and when it comes out, it's called lava, and ash cloud is released, which is very important, and it's very dangerous. So what is the difference between magma and lava? Again, magma is beneath the Earth's surface. It's the molten rock beneath the Earth's surface. However, when it's released outside of the Earth's surface, it's called lava, and it's very hot. What is pyroclastic flow? Remember when I say there is ash or dust released from the eruption? These eruption release pyroclastic material or flow, this mixture of solid and gases. The volcanoes that occur, they're not all active. Some are active, some are dormant, some are extinct. The major volcanoes occur at hotspots, very famous, very strong eruptions, such as the Mount Mauna Loa in Hawaii. Yes. So what are the types of volcanoes? We have different types of volcanoes according to the eruption and the gas content released from the eruption. We have lava dome volcano, stratovolcano, shield volcano, and cinder cone volcano. The more silica or silicon dioxide released, the more viscous the lava is. Okay? The more gas released, the more explosive the eruption is. So as you go upwards, the viscosity increases, and if you go on the right, the explosivity increases. Example, the most explosive and highly viscous is Mount St. Helens in Washington, and it's a stratovolcano type of volcano. As you can see, the diagram, the dust and the particles release is very high because of the high gas content and high silica content. On the other hand, diagonally, you can see the shield volcano is the least viscous and the least explosive due to the low silica and low gas content. So what do you think are the effects of volcanoes? Are there only negative effects, or there might be positive effects? Of course, the negative effects is much more higher because it's very destructive, and it have a very negative impact on our environment, on humanity. However, the positive effect is that the release of gases and minerals from the volcanoes renders the area around the volcano to be very high in agriculture due to the minerals released. Yes, if people would like to plant material, plant lots of green leaves and things like that, agriculture, it would be a very good medium. However, it's very dangerous to live there. Let's go on to the second natural phenomena, which are earthquakes. Do you know that every 30 seconds in the world, so right now, if you count 30 seconds, there's an earthquake somewhere in the world? Yes. But do we sense it? No. We only sense the really strong earthquakes or the moderate earthquakes. So what are earthquakes? Earthquakes are ground movements that occur when blocks of rock in earth move suddenly and release energy. So it happens along cracks in the earth crust where there are points in the earth crust that is weak. So when it's weak,